time on the water more productive. Unlike typical sonar, which looks straight down below the boat, side imaging sonar uses a razor-thin beam that projects up to 240 feet to both sides of the boat for 480 feet of coverage across the bottom. Though they look like photos, these are sonar images and are not dependent on light. Darkness or even mud and silt will not interfere with side imaging. Natural structure, submerged wreckage, boats, automobiles, and even schools of bait fish show up in hummus from top to bottom instead of right to left. The most recent images will be at the top of the screen, with your history moving towards the bottom. Your boat location is top center of the image. Let's focus on the water column. To give you a better idea of what's going on with the Humminbird side imaging screen, we're going to fold the image down the middle. Now we can clearly identify the water column directly below the boat. This wide dark-colored band is the water between the surface and the bottom. Any activity in this area took place in the water column directly underneath your boat. The gradual changes in width of this band will give you an image of the bottom profile as well. Next, we'll again fold the screen where the water column meets the bottom. At this point, the sonar is identifying structure to the left and right of your boat. Rising and falling terrain, rocks, timber, and man-made structure will all be visible along the bottom in picture-like detail. This simple 3D visualization makes the Humminbird side imaging screen incredibly easy to understand. Now let's take a closer look at what appears on the screen. Flat-bottom terrain will appear as a neutral shade of blue. Descending terrain appears as a darker shade of blue, while terrain rising from the bottom will appear in a whiter shade of blue. One of the easiest ways to identify structure with Humminbird side imaging is to look for shadows. Objects standing off the bottom typically appear as a bright spot immediately adjacent to a dark sonar shadow. These shadows are caused by the object reflecting the sonar energy and often tell you more about the height and shape of an object than the primary sonar reflection. Finally, Humminbird side imaging also shows fish. Schools of bait fish will appear as a cloud or cluster of small white dots. Larger individual fish show up as small white lines or streaks on the screen. There are many variables that
into the subsurface rock at the bottom of the ocean. To give animals that may be sensitive to this sound time to leave the area, the surveying process begins with a soft start, a technique that gradually increases sound to full operational levels. The survey is conducted by a ship towing a compressed air gun, which fires in regular intervals, and a large array of sound sensors that record how long it takes for the sound to bounce back from the layers of rock under the sea floor. From the recorded data, detailed three-dimensional maps are produced. These provide engineers the information they need to develop a production plan in order to tap the highest yield reserves. The maps also pinpoint the safest and most efficient drilling locations, eliminating unnecessary drilling and reducing the number of dry wells. If visual observers or acoustic monitoring devices detect sensitive marine life in the vicinity at any time during the survey process, then all operations stop immediately and are restarted only when the area is clear.
Ship Nancy Foster zigzags through the water using sonar to scan the seabed. The ship emits more than 3,500 pings per second in a wide fan, creating an image as if painting strips of data across the sea floor. Weeks of back and forth reveals a lot more than depth. Based on the intensity of the echo, scientists can tell if the bottom is hard, sandy, soft, covered in coral, seagrass, or other soft plants. By combining the sonar data with direct observations, NOAA creates
a bit of pulse of sound or a ping, that ping is transmitted through the water column, and it reflects off of anything that's in the water column that's of differing density than the surrounding media. That could be the bottom, which is very hard. It could be air bubbles that's produced by wakes, waves, or boats, or it could be gas bladders or swim bladders in the case of fish.